Okay, everyone, let's continue looking at Module 26.210, Circuit Breakers and Fuses, in the NCCER 11th edition. This will be Section 2.00, Sizing and Selecting Circuit Breakers. A circuit breaker is a device used for opening and closing a circuit in the case of an overcurrent event. As long as the circuit breaker is applied within its rating, it will automatically interrupt a fault. There are three types of circuit breaker operations: thermal circuit breakers, magnetic circuit breakers, and thermomagnetic breakers. Upon sensing an overload, a circuit breaker opens its contacts. When a breaker trips, the handle jumps to the middle position. Circuit breakers are classified into their ampere groupings. The established voltage rating of a circuit breaker is based on its clearance between conductive surfaces. A circuit breaker voltage rating must be equal to or greater than the voltage of the electrical system to which they are used. A circuit breaker can be rated for alternating current AC or direct current DC or both. Circuit breakers have two ratings: continuous current rating and fault current interrupting capacity. Generally, the circuit breaker current rating must be equal to or less than the low current conductor carrying capacity. A circuit breaker's ampere rating interrupting capacity, or AIC, is the maximum short circuit current in which the breaker will safely interrupt the circuit. If the AIC is based on the rated voltage and power frequency, fuses and circuit breakers must have a high enough rating to withstand the highest current they may be exposed to without damage. Fuses and circuit breakers are designed to clear fault currents. The interrupting rating of electrical equipment is divided into two categories: current at fault level and current at operating levels. If an extreme fault current exceeds the interrupting rating of a device, it will be damaged or destroyed. The intent of the NEC is to ensure that short circuit currents cannot exceed the ratings of the system components. There are three main categories of interrupting capacity: standard, high, and current limiting. Here we have interrupting capacity rating example. On the left they have inadequate capacity and it is destroyed. On the right they have adequate interrupting capacity and the fault is cleared. Interrupting capacity rating: a current limiting circuit breaker is essentially a thermomagnetic circuit breaker with an independent limiter section in series with each pole. Above the threshold of current limitation, the limiter contacts opens and an arc voltage is generated to limit the peak current allowed to pass through the faulted circuit. The resistance of the arc forces the current to transfer to the alternate path provided by the limiter resistor. During the cycle of the limiter section, the breaker tripping mechanism activates and the contacts interrupt the reduced fault current. Regular maintenance of circuit breakers and their enclosures is necessary. Series rated systems. UL recognized series rated systems require special markings. Equipment enclosures for circuit breakers and fuses must be legibly marked in the field. The markings must be easily visible and include the current rating of the system. Ground fault circuit interrupters. A fault current exists when an unintended path is established between the ungrounded conductor and ground. Depending on moisture, vascular structure, and voltage, the hand-to-body resistance of an adult lies between 1 and 4,000 ohms. A conventional overcurrent device will not open to prevent bodily harm. There are two types of ground fault circuit interrupters. They are the feed-through and the non-feed-through. GFCIs are required on certain circuits and specific applications such as bathrooms and rooftops. GFCI circuit breakers continuously monitor the current in the circuit's two conductor wires. If a difference of more than 6 milliamps is detected, the GFCI automatically opens the circuit. Other types of circuit breakers. There are many types of circuit breakers with a variety of characteristics. Some include shunt trip circuit breaker, arc fault circuit breaker, GFCI breaker, switch neutral breaker, and non-automatic breaker. And here's some trade terms you should read over and become familiar with for this section, and some review questions for this section. It says a 250 amp fuse has a frame size of 250 amps, 300 amps, 350 amps, or 400 amps. And that would be 400 amps. At 300% of its rated current, a circuit breaker rated at 600 volts must trip within 7 milliseconds, 0.7 seconds, 7 seconds, or 70 seconds. And that would be 70 seconds. All right, everyone, that's it for that section. Next section will be 3.00, sizing and selecting fuses, and I'll see you over there.